Greetings, math friends. I am literally in my basement. I'm concerned that students are struggling to do partial fraction decomposition. So I'd like to go over a problem where it's not a linear denominator, but it uses the same tactics so that students have a fighting chance. Join me. Alright, we're going to start with the rational function of 4 over x cubed plus 4x, and we want this to break down into two fractions that add together. So I'm going to put the placeholding fractions in here. I need a numerator, a, and b, and then I need the denominators. The denominators are going to be factors of this. If we look at this, we can use the greatest common factor and factor an x out of this. X cubed divided by x is x squared. And then 4x divided by x is just the 4. When we look at this, we have x squared plus 2. We see this is a square and this is a square, but it's a sum of squares. If it had been a difference of squares, we have a factoring method for that. Since it's a sum of squares, we don't have a factoring method for that. This essentially is a prime quadratic. It doesn't break down into further pieces. So the denominator of a, we're going to call the x that we have out front, and the denominator of b, we're going to call the x squared plus 4. So we see we have a linear denominator and a non-linear denominator, and that's what really makes this different, is that we don't have linear denominators. So we have to figure out how to deal with a non-linear denominator. To make these proper fractions, and to work for what we're trying to do of the partial fraction breakdown here, we want the numerator to be one order different from the denominator. In this case, we don't see the x here. We would say this is x to the 0 power, which is just 1, and 1 times a is a. And this is x to the first power, so we have a degree of 0 and a degree of 1. To get the same result here, we need an x here. So x to the first, x to the second, 1 and 2, degree 1, degree 2, so they have a degree difference. So that's the big change. We add an extra x in the numerator here to get the format that we need. And then from there, we're going to use all of our normal skill set for finding these partial fractions. So we're going to multiply through here by the denominator, and that's going to cause some cancellations, and we're going to go ahead and do that. So when we look at this, we'll have 4 here because this denominator is canceled because we're multiplying through by this denominator. Over here, out of this, the x cancels out of here, leaving the x squared plus 4. Over here, this is canceled out of here, leaving the x behind, but since there's already an x, we have an x squared here. We can distribute this to simplify. We'll have 2 x squares when we do that, and we'll be able to bring that together. So now we have the a squared and the b squared here. We can bring that together as a plus b in parentheses x squared plus my 4a here. And that's still all equal to 4. We need to set these coefficients equal to the coefficients on this side. We don't see an x squared over here on this side. We do see an x squared here. We have a number here, and this essentially is a number here. Over on this side, what we really have going is that the coefficient of x squared over here is 0, which means a plus b have to equal to 0, which means these are additive inverses of each other. If we know one or the other of these, then we will know both a and b. Secondly, if we look at this, 4 times a has to equal 4. This is the only number we have here, which means that 4 is equal to 4a, which means that a has to be 1. If a is 1 here, then that means b is negative 1 here, because they have to add up to 0, because the x squared is missing here. So at that point, we can come back and look at the original. We can replace the a with the 1 that we solved for, and the b is really negative 1, so I can just put a negative in front of that, and that means that this will be our final solution. 4 over x cubed plus 4 is going to be equal to 1 over x plus negative x over x squared plus 4. Hopefully, this gets you out of the basement of your problem confusions with the partial fraction decomposition. Cheerful calculations.